So for question number 4, we take a slightly different approach. A is asking us first about the population, um, what I'm going to jump into is, so then I jump down here, I see significance of 10. So I see the level of significance. This is helping me understand the test, and it is a two-tailed hypothesis test. I rarely read in order. I just look over and say, okay, what's the important stuff? B is going to tell us the type of test we're going to do. We'll sketch that down here. And actually, this is all we need to get set up. So I'm going to go with the gray, and I'm going to come over here, and it's a 10% test and a two-tailed. So um, this is going to help me set it up with these z values, negative 6.645 and positive 6.645. 0.6. Wow, that's way in here, right? Here's negative 1. Here's negative 0.5. 6.5 is maybe like way in here. Looks like this should be easy to reject, right? But we'll see. I mean, for a two-tailed test, I don't know if I believe that, but anyway, that's supposed to mean that like 90% is in here. It's the first time I'm doing this, but yeah, I saw some of you doing this, and it really, you're going to have that. It looks like a huge rejection region. However, in reality, this must be the 90% in here. Um, just a moment. Let me check that out. This just doesn't seem right to me. So if it doesn't, this a little bit of a side, we can always go to distributions. This is how we can figure it out. We're going to go to the normal curve. We are going to leave it as a standard normal, so 0 and 1. And then we're going to come over here and do a two-tailed, which means between. It's actually, we're going to get the area between. And then instead of putting in numbers here, we're going to put in 90% in here, 0.9. It just doesn't feel right to me. It's, oh, see, they got those wrong. It's negative 1.64. See, I didn't, somebody pulled things off the internet. It tells you got to check things out. Um, and it's closer to this one here, right? Because this would be 5% on one side. So, um, apologize for this. They made an error here. 10% means a 90% confidence, right? This always has to add this 95 means, or this 5 goes with a 95%. So there's an error in these notes. I'll highlight that in class, but until then, what we're going to do, come here with some dark, and we're going to say this is 1. Just didn't feel right. It's going, no, this, um, they were wrong. They lied to us. That's not nice. Uh, we're going to come back here, take this out. And that's the nice thing. The calculator is going to verify this for us too. We'll see that it's going to have the line in a different place, so the rejection region. Let's come back here. Let's go with the gray. Negative 1.645. This is going to be more like here, a little bit more than half, something like that. And positive 1.5, here's a 645, something like this. Something in here, 645, and then negative 1.645. That's more of a tail. The other one wasn't really a tail, was it? Um, I apologize, I didn't pick up on that when I saw some of you working these in class, but I guess I wasn't looking at detail, and I was just going, that can't be. Um, so anyway, the truth we can always find out here. And so we're going to go back here. Let's go back to inferences, and well, actually, let's read, and we'll get this set up. So data published by California salaries of state workers indicate the average yearly salary of full-time secretarial staff at state universities is 47,500. So that's our population that we're talking about here. Full-time secretarial staff. Describe them, full-time. They described it for us, right? But I think that's why they asked this question a little out of, who are we talking about? And even though at the beginning they mentioned that this is coming from the salaries of just state workers, we're not talking about all state workers. We have picked on the salary, the average salary of a particular class of state workers. So our this is our population that we're working with right here. But it'll be secretarial staff at all state universities, full-time secretary staff at all state U's. Okay. We examine whether the mean salary for secretary staff at a particular one, CSULA, um, is different from the state mean. So that's different. So the null hypothesis, what they're telling us is that we're given this 47,500, and we think it's different. Trying to say whether it's different. So that means that's why it's a two-tailed test, right? Um, that means that our belief is that it's not equal to 47,500. So we'll put that in as our hypothesis test. We've got our sample information here, 64 full-time staff members, and 49,000 is what they have, standard deviation of 6,200. Okay, so we're going to plug those in. We're going to run the test. We'll see this, and then we'll be able to talk about our results. Here, uh, since we are getting the sample, standard deviation is coming from the sample, we want to back up enough to make sure we're doing a t-test. Even though the sample is large enough, that would be okay too, but just technically, okay, so we're at 300. What do we want to put here? This is where we want to put 47,500. And then this, and notice it gives us in scientific notation, this is 10 to the fourth power, so move this decimal, it's going 4.75. But that's okay. We'll be okay with this. We just need this one to be the not equals. And then we come through, we can input our statistics. Our sample had a salary of 49,000. Our standard deviation was $6,200, and our sample size was 64. We are doing a significance level of 10%, 0.1. Yeah, that's still correct. So we'll stick with that. And we go to next. Our test statistic is 1.93, and it's a positive 1.93. So let's draw that on the map here. It's 1.93, kind of close to 2, right? Because 1.9 would be about there. I don't know, about here is what we're going to estimate. And then, so this is the t statistic, right? The test statistic. This is the, in gray, what we have here. This is the t critical. This is also a t critical. We're both ends, right? This is a t stat from the population. And then what's going to happen is when we shade this region, that's what the calculator will do, that it gives us a p-value of 0.057, 4, if you want 4 decimal places. Actually, that's the area there and here, because it's a two-tailed test. So you'll see it splits it between the two, but the total area is about 5, almost 6%. Our significant level alpha is 10%. Should have labeled that better here. 0.10. That's the gray area, which is split on both sides. So that's 5%, 5%. So this area at the right, the yellow area, will actually be, I guess I should make sure this is referring to both sides. This p-value is both of these areas. So half of them is about 2.5. All right. So anyway, it's definitely in the rejection region. That's what we're looking at. and we had a p-value 0.0574, we see that that is smaller. P is smaller than alpha. Colors, just color coding is always good. P is less than alpha, so that's where we are going to reject. This gives us the information to reject the null, H naught. So we can reject H naught. Let's talk about this, what this means. So what is the result of your test? We reject H naught, and which or something we have, and we have strong evidence that salaries for secretarial staff, right? For secretarial staff at CSULA, because this is specifically at CSULA, is different than the state. Because that was, we took that right from here. This is the mean salary for secretarial staff at this is different. State mean. The state is going to say that than the state mean. Okay. Are we saying it reflects sampling error? Well, again, what kind of error could there be? Some of these questions are just kind of out there, but there's only two types of errors, right? So since we, in this case, we rejected it, it would be, if there is an error, it would be a type 1 error. Type 1 error is not from sampling. No, yeah, generally not from sampling. It's a type 1 error is we rejected when we shouldn't have rejected. But no, I'm going to say no. If there is an error, it would be type 1 error. The thing is, it could be, sampling could be involved that we might not have taken. It might not have been really random, but we don't know. They didn't give us all that information, did they? A sample of 64 full-time members. They don't say it's random, so that, yeah, I mean, it's not that we might, we still could have sampling error, but this is the only, because of our decision, if we're going to have an error, it will be a type 1 error. So that's what I'd say, that sometimes you just don't answer people's questions that don't seem to make much sense. I don't know if it's from sampling or something else, but it's a type 1 error if it happens. But okay, so that's good. Thank you.